All right, this is a review for the array and array list test. So on problem 1, we're given an array of integers. The first thing we do immediately is to always write the indices above them so we can easily change them without recopying or recounting each time. Remember that the index always starts at 0. So numbers at position 4 is now going to become 5. And then we have numbers at position 2. We're going to add 2 to it. And then here at numbers at position 3, we're going to take numbers at position 0, which is 2, and then add it together with numbers at position 2, which is now 8. So this gives us 10, and that goes into position 3. So our array has become 2, 4, 8, 10, 5, which is A. Right here, it's initializing a array of integers called my list of length 6. So 1, 2, 3, 4, 5, 6. When it's first instantiated, it gets its default values. And remember, for an integer, the default values are 0. The next line is traversing the entire array. It's starting from 0, and it's going all the way to my list.length, and it's increasing by 1. And what we're going to do in each piece is we're going to put its position squared. So 0 times 0 is 0. 1 times 1 is 1. 4, 9, 16, 25. The next line here is an enhanced for loop, or a for each loop, and it's just printing it. So we're just printing that exact array, so B. All right, so here we've got a couple of different things. Let's write out the array first. So 0, 2, 4, 1, 3. And our indices are 0, 1, 2, 3, 4. We're traversing the entire array. So let's see, start with I is equal to 0. So if I is equal to 0, we're going to have A0 is going to equal to A0 plus 3 mod A.length. And A.length is the length of the array, which is 5. So if we take A0 plus 3, we're going to get 3. So we're going to have A of 3 mod 5. Remember, modulus tells us the remainder. It doesn't go in there at all, so it is all remainder. So at the 0th position, we're putting the third one. Increment our I. So now we're going to have A1 is going to equal A1 plus 3. Then again, mod 5. So A1 is 2. So 2 plus 3 mod 5. 2 plus 3 is 5. 5 mod 5 is 5. So A1 is going to stay as A1. And that's exactly what they wanted us, what A1 was going to be. And the next time we're going to be incrementing I again, so we'll be looking at position 2, then position 3, position 4. A1 is not going to change anymore. So A1 is going to stay at 2. So the next one wants to know what this method does. When we're looking at something, if we want to just kind of run through it, make up an array. It doesn't matter what array. We know that it's going to be an integer array. So I'm going to go ahead and say I have a list. And I'm just going to put just a couple numbers in here. I'll put my indices up at top, just like always. So what happens here is that we are making a temporary array, and it's going to be list.length. So list.length is going to be 5. We're making a new array the exact same length as list. It currently is at default values. So now we're going to traverse the entire array. And let's see, if I is equal to 0, you're going to have temp 0 is going to equal to list, in which was 5, minus 0, minus 1 is 4. So whatever was in list 4 is now going to go over there in temp 0. Okay, let's go ahead and do another increment and see what happens. So what happens if I is 1? We're now going to get temp 1 is going to equal to list 5 minus 1, or list 3. So what was in list 3 is now going to go to temporary 1. And what's happening to this? It looks like it's reversing the array. So let's see, to make another copy of the array, it didn't make the exact copy. To make an array copy, nope, oh, in reverse order. And I believe that's what we did. We just put it in reverse order. Read through the other ones just to make sure they are not correct. Scrambled copy, it's not scrambled, we can predict what it's going to be, and then negatives, no. So we have a find max method. They told us our max value is equal to 0. We're going to traverse the array. If our value is bigger than our max, we found our new max, the max will be max value, and after the loop, it's going to return the max value. So this method is intended to return the largest value in the array. Why does it not work as intended? Well, what happens if our array was all negative? You've currently set the max value equal to 0. So is any value inside of that array going to be bigger than 0? No. So you're always going to have your max value, which is 0, and that's not even in the array. So if all of them are negative, it won't find it. Remember when we talked about this? There's two ways we can fix this. What I prefer to do is I'm going to always set the max value equal to the first piece in the array, because then you're actually comparing it to things inside the array. The other thing you can do is set max value at the integer min value. Then obviously the first one's going to have to be bigger than the integer min value, because otherwise it would do overflow. Okay, consider the following method. So we've passed in an integer and an integer array of numbers. We're traversing starting at 1. We don't traverse the entire array, and we're not going up by 1 each time. Which of the following represents the order of the values and numbers as a result of the following code? Okay, so first put our numbers, so indices. We passed in 3, so that's going to tell us that our x is equal to 3. And this is our numbers. All right, so let's go through it. So k is equal to 1. So numbers k, so numbers 1 is going to equal to numbers 0 plus x. So number 0 is 17 plus x, which was 3, is going to be 20, and that's going to go into position 1. Now we're going to have to add 3 to k. So that now makes us k is equal to 4. So now we're going to go through and do it again. So n at position 4 is going to end up being n at position 3 plus x. So at position 3, it's 42. We're going to add 3, which will give us 45, and we're going to put it in the 4th position. Again, we increment k by 3. And we're going to have numbers 7 is equal to numbers 6 plus x. So 48 plus 3 is 52, and we're going to store it here. So let's see, 17, they all start with 17 except for this one, so we can eliminate that. The next one we know is 20, so we can eliminate that. And then 21 was not touched. Again, when you're traversing arrays, make sure that you pay attention to where it starts, if it goes all the way to the end, and if it increments by 1. All right, so this is our first array list question. Remember, array list have to take objects. Regular arrays can take primitives or objects. So this is the integer object class. Remember, it already auto-boxes and unboxes without us even knowing. I wrote it here without auto-boxing. I'm telling it to put in the object integer 22. You could have just said nums.add 22, because it will automatically box it as a object and then unbox it as we need it. I just wrote it this way because it looks different and we usually miss it. Okay, so let's see. I'm going to add 22. We're going to add 10. We're going to add 13. Remember, if it says just add, it always adds it to the end, unless it's given a position. So here, now it says add at position 1. So here's 0. So now it's going to be added right here at this position, and we're going to add 21. So I'm going to go ahead and rewrite the array. We're going to set at position 0 to 2. We're going to remove whatever's at position 2. So my final array is 2, 21, 15. All right, so this is an array list problem where we have a bunch of strings are inside the array. Here we're going to traverse the entire array. Remember, when you have an enhanced for loop, it has to traverse exactly in order. You can't skip anything and you can't modify anything. The only thing we can do with for each loop is access the elements. So this is the compare to method. So if we have a dot compare to b, it's checking if it's in lexicographical order, which for us is going to mean is an alphabetical order, because AP is either going to give us all lowercase or all uppercase. And remember, you can always do dot to lowercase, dot to uppercase if you need to compare them alphabetically. So here, if compared to B, that is in alphabetical order, it's going to give you a negative value. It gives you exactly how many positions A is in front of B. The next one would be B dot compared to A. This is not in lexicographical order, so it's going to give you a value bigger than 0. So we're going to pick up grass. So we're going to compare grass to garden. Are those in alphabetical order? No, so it's going to give you a value bigger than 0, and since it's bigger than 0, it's going to print it. So I know the first thing it's going to print is grass. We go to the next one, and we're picking up tree. And we're going to do tree dot compared to garden. Are those in alphabetical order? No, so it's going to give you a value bigger than 0. And if it's bigger than 0, it's going to print it. So now it's going to print tree. We increment again, and we have bush. Bush dot compared to garden. That is in alphabetical order, so it's going to give you a value less than 0, which means we're not going to print it. Then we're going to have leaf compared to garden. Is that in alphabetical order? Those are not in alphabetical order, so again, it's going to give us something bigger than 0, so we're going to print out leaf. Then we're going to go to garden. If you compare garden to garden, those are exactly equal. So that's going to give you a 0. So we're not going to print it. And then we pick up flower, and flower is ahead of the alphabet than garden. So it's going to give you a value less than 0. So you're not going to print it, and your answer is C. Make sure you get this memorized. A dot compared to B, if it's in alphabetical order, it gives you a value less than 1. If it's not in alphabetical order, it gives you a value greater than 0. And then if they're exactly equal, it's going to give you the value equal to 0. So we have an array called values. It's calling the method fun. So we go to fun, and we pass in that integer, and the only thing it's telling us to do is take the index 0 and add 1 to that element. So that now becomes 4, and then it asks us to print that value. Here we have an array list of animals. These are all strings. So we're going to add chicken. At position 0, we're going to add horse, so it's going to go in front of that. We're going to add cow. Since it doesn't have a position, it pins it to the end. We're going to set at position 2, so 0, 1, 2, so cow's now going to become goat. And then we're going to add at position 1, sheep. So our array is currently horse, sheep, chicken, goat. We're going to print animals.getTo, so 0, 1, 2, we're going to print chicken. Concatenated with and. Animals.getThree, which is going to be goat, so chicken and goat. Okay, so we have a lot going on in here, so let's just start, writing things down that we know. We know that our index is equal to 0, count is equal to 0, m is going to equal to -1. We passed in an array of integers, so I'm going to make up an array. Put our indices on top just so we can keep track of everything. We're going to have an outer loop, and then inside there we're going to have an inner loop. So we're going to start our outer loop at 0. Notice it traverses the entire array, increments by 1. When we enter this loop, the count gets set back to 0. Now we're inside the inner loop. It starts at outer plus 1, and then it'll traverse the rest of the array. So the first line here is saying if array of outer is equal to the array at the inner point, then you're going to increment your count. So basically, if the two values are equal, you're going to increment the count. So is array 0 equal to array 1? That's false, so we don't increment our count. So we go up to the, here, go back to this for loop, and now our inner is going to increment to 2. So then it's asking if array at position 0 is equal to array at position 2. So is 0 equal to 2? That is true. So now my count is going to go back to 1, or go up to 1. We go back up there, and now our inner is going to become 3. So we're going to check if A0 is equal to A3. That's not true. And it won't be true for the rest of the thing. All right, so then let's see, after we go through this loop, the count is not going to change, so we're going to go here. So if count is bigger than m, so yes, count is bigger than m, so index is going to become outer, index is now going to become outer, which is still 0, and m is going to become the count. Go up here, all the way back to the top. Now your count goes back to 0, and our inner is going to start at outer, now our outer is going to be 1, and then we're going to start our inner at 2. So now we're going to do the same thing. We're going to compare this one to every single one. So we're basically trying to figure out what appears the most. What is the mode of this? And lastly, let's see what it asks. Assume that nums has been initialized. What is being returned? Well, it's returning index. So let's go up there and figure out what exactly index was. And it's going to give you the index of the value that occurs most often. So it didn't actually give us the mode. It gave us one of the indexes of the numbers that appeared most often. A student wants to create a method for a unit project and wants to allow classmates to use it freely without being accused of copying. What should he do? Post the method with no credit or license? Submit the method privately? Well, if he wants other people to use it, just don't do it privately. Clearly state that the method is up for public domain, or password protected. So clearly C. Now, these type of questions are new this year. They're really looking for like overarching ideas in data structures. So we have array of strings. We're picking up an element in names, and then we're grabbing its substring. Since from 0 to 1, remember you include 0, you don't include 1, so we're only picking up the first letter of each thing, and then we're printing it. This is an enhanced for loop, so we know we're starting at the very beginning and going to the end and not skipping any values. So all we're doing is picking off the first letter of each word. All right, another array list. We've got animals, it looks like. So we're going to do zoo.add new animal, zoo.remove. So far I don't think anything's happened. Oh, we want to know how many, what's the size of our zoo? I'm sorry, size. So if we add an animal, we now have 1. If we remove an animal, we now have 0. We add a new animal, we got 1. This is just creating an object. We haven't added anything. We added another, it's 2. We add another, it's 3. Remove, 2, add, remove, and then add. So I believe we have 2 animals at our zoo. Which of the following correctly initializes an array to contain 4 elements, each with a value of 0? This will definitely work. This one will definitely work because when we do that, it's going to set everything to default. Now this one's saying we're going to have that default array, but then it wants us to do an enhanced for loop and change it. Immediately, you can't change things with a for each loop. They can only access the elements, so only 1 and 2. Okay, so we have a class called iPad, and we have several methods in the iPad class. Here's, we've got a full charge battery, and then a charge. We want to know, is it fully charged? Is there a low battery? And then we have a second class called inventory. Inventory is an array list of iPads. To add a method that can count how many iPad objects in the inventory are charged at less than 20%, which of the following is true? The method could be implemented in battery or inventory. That's not true. In the battery class, we only have things on 1 iPad. In inventory class, we contain the array list of all the iPads. The method cannot be written because the array list is declared private. Nope, as long as you're in the same class, you can absolutely access that, and if not, we can use getters and setters to get to them. The method should be implemented in battery. No, because again, battery has to do with 1 iPad, not an inventory of iPads. The array list is living in inventory, so it must be D. Which of the following methods could not be implemented in iPad? Well, is fully charged, that has something to do with only an iPad. Is low battery, that has to do with 1 iPad. Get charged has to do with 1 iPad. So it's got to be get inventory. Remember, everything in inventory is going to have something to do with possibly the array list. If you're in the iPad or battery class, it only has 1 thing. The following method in inventory is intended to count how many iPads are fully charged. What would go in the missing code so that the method works as intended? So we want to know how many of them are fully charged. Part for A. This is only looking at what's calling inventory all at once, which is an entire array list, and you can't just ask if the entire array list is charged or array. So no, we didn't do any type of loop. This is just counting how many iPads are in the inventory, because if I is in inventory, we're going to count it, so that's not right. C is asking if it is charged to 100%, then we're going to count it. And we only wanted it to be, let's see, fully charged. Oh, but we didn't use a method. Right here, we're just grabbing that variable. That's not a method. We have to grab the iPad and use the method is fully charged, then count it. Which of the following methods correctly removes and duplicates any duplicate words? Replace one after another in an array list. So we want to remove something from an array list. Remember, we've talked about this. If you're removing something from an array list, you must traverse backwards. Well, not really, you have to, but it makes things so much easier because otherwise your counts get off. Because as we remove something, your length went down, your index has changed. So this one's not traversing backwards. And it's also using an enhanced for loop. Enhanced for loops cannot change things. This is not traversing backwards. This is the only one that traverses starting from the endpoint. This is one of those new data structure questions. An educator wants to investigate whether students who take notes digitally are more likely to complete online courses than those taking traditional notes. So which of the following data sets could be used? Data set A, it has a student ID, note-taking method. Well, we definitely want the note-taking method. B, student ID, course ID, and whether the class was completed. Data set C, course ID and instructor rating, has nothing to do with this. Data D, student ID and average quiz scores, so no. The two things we need are A and B. Write a method that will accept an array of integers and find the second largest element in the array and return the index that that's found at. Okay, so first thing I'm going to do is find the first largest. Because if I find the first largest, then I can try to find one that is smaller than that, but still larger than everybody else. So let's say we want to return an index, so we're returning an int. We're passing in an array of integers. So let's see, public, static, int, second largest, and we're passing in the array of integers. I'm going to call it nums. We want to know the index of the second highest. So we really need to keep track of not only the max, but also the max index for each thing. So first thing I'm going to take my int, my max is going to be at position 0, because remember we always set this to be num0, the very first element. So our max is currently at num0, so that way we're comparing to stuff in its data set. And then int, the position of that max, we're going to set to 0. So now we have to traverse everything in nums and see if we find something bigger. If we find something bigger, then we're going to change the max and change the position. So for int I equal to 1, I can start at 0. I just don't need to because I've already put my max at the 0th position. But if you start at traversing at 0, it's just not going to do anything on that step. That's okay. I less than nums.length. I plus plus. So we're going to pick up an element and we're going to say if max is less than nums at position I, that means we found a new max. So our max is now going to become nums at position I. And we found a new max, so we also got to change our position. Our position is now going to be I. So at the end of this, we're going to have a max and a position. So this right here just finds the overall max. Now we're going to do the same thing, but we're going to find the second max. So I'm going to call that int second max. And again, I'm going to set it equal to the first position. So num0 and again, I'm going to do int my second position is going to be 0. And now we're going to traverse the array again. So for int I equal to 0 or 1, I less than nums.length. So now we got two things to check. We got to see if it's a new max and it's less than the first max. So if we need nums I to be bigger than, less than the overall max, and we want nums I to be bigger than the second max. So again, now we need to, if we find this, we go through, that means we found a new second max. So second max is now going to be equal to nums I. And our second position is now going to be at I. And the last thing I want to do on this is return second index. So second position. All right, so this question, we have library books on shelves in the library. So I have a book class. In the book class, we have the getter of get title. There may be other things we don't see. So now we have a library class. A library is an array of books called shelves. We have occupied shelf indices. Part A, write the occupied shelf indices method in the library class. The method should return an array list of the indices of shelves that are not null, meaning they currently hold a book. The order of the indices list does not matter. Complete this method below. Okay, so let's see. What did it want us to do? It wants us to return an array of books that are not null. So public static. Now if I'm going to be adding things dynamically and I don't know how many items are in there, I'm going to use an array list. So we're going to use an array, we're going to return an array list of data type integers. Is that integer? Yeah, integers. And occupied shelf indices. I just don't want to write that all out. So first thing, we have to create a new array list. So array list of integers. The result is going to be equal to a new array list. I'm going to use a little shorthand here because I'm trying to not write so much. Make sure it's a method. We're going to traverse our original array, which was shelves. It's a regular array, so we use dot length. So if shelves at position I, if that's not equal to null, that means there's a book in there. If there's a book in there, we're going to add it to results. So result dot add shelves I. And at the very end, we're going to return that array list result. So write the stock shelves method in the library class. This method should place books from the books to stock list into the first available no slots if this in the shelving array. Books are assigned in the order they appear on the list. Once a book has been placed, it needs to be removed. Okay. So let's see what we have here. We had our shelves. Shelves was a regular array. And then we had our books to shelves. That's an array list. And we want to return, no, we don't want to return anything. Okay, just want to void. So public void stock shelves. And you're passing in your array list of object books. So we're going to traverse our regular shelf array and look for a null space. If we find a null space, we can potentially add a book, but we need to first make sure there's a book there. If there's not a book there, then obviously we can't add anything. So we're traversing shelves. So if, oh, not if, for. So we pick up an item in shelves. So if shelves I is not equal to null, that means we have, no, we want to know if it's equal to null, because if it's equal to null, that means we can add something to it. So remember, we're checking for equality, so that's 2 equals. And we need to make sure that we actually have books to shelf. So if books to shelf or stock, and that was an array list, so dot size, if that's bigger than 0, that means we can add a book. So we need 2 things to happen. It needs to be null on the shelf side, and we have to have something in the books to shelves. So if that's true, then we're going to add the book. So shelves I is going to be the books to stock dot remove 0. Now I could have done this last one in more steps, but if you remember when we do the dot remove method, it actually returns the thing that was removed. So I actually don't need to add it and then remove it. I can remove it all at one time.